Welcome to BKW Physics. I'm Mr. McConley, and today we're going to do a combination circuit, a combo circuit, which consists of some series elements along with some parallel elements. And what makes this one different than any one we've tried before is that when I've given these to you guys before, I've always had it so you go through a resistor in series, and then you have a branch or a few branches in parallel, and then the electricity just come back to the battery. This time I've thrown a little extra kink in that there's a resistor down here too. This doesn't really confuse things that much, but let me teach you what you have to do to make it come out right. So step A. What do I always tell you is the first step in solving a combo circuit? That's first approach. Okay, so I got all these listed, total resistance, all the resistors, total current, all the, what do you want to find first? Totals. And resistance total is a good one to start with. But first let me label that I have 5 ohms here, I have 10 ohms here, I have 12 ohms here, I have 15 ohms here, and I have 6 ohms down here. So I want to find the total resistance. And my technique consisted of what? Well, my technique said you take the 3 parallel, or however many parallel ones you have, and you combine it so it's really like one resistor. So I'm going to do this. This is the parallel resistance part. I'm going to say 1 over R total is equal to 1 over 10 ohms, plus 1 over 12 ohms, plus 1 over 15 ohms. And I'm going to combine those as a parallel circuit resistance. And remember, there's 2 ways you can solve fractional problems. Way number 1, find a common denominator. Play that out. The other way is do 1 divided by 10, 1 divided by 12, and 1 divided by 15 on your calculator. Get to the end, hit the inverse button, and flip your calculator, flip it back over. I don't care how you solve it, you just mathematically have to do it correctly. So, all really being told, by the time I do this on my calculator, whatever I choose, I get 4 ohms. And this is not really a total resistance. Instead, I'm going to relabel this. I'm going to relabel this as it's the resistance of resistor number 2, 3, 4. That's so I don't confuse myself. Because if I label it total, it's not really the total, it's just the parallel part. But now I've taken these 3 and I've got it so they're like one resistor. They're a 4 ohm resistor. Now I can actually find the total resistance. And now am I treating it like parallel or like series? Series. Because I'm going to take that resistor, R1, I'm going to add it to this resistor, which we call R2, 3, 4, for lack of a better term. And then I'm going to add it to resistor number 5. So the numbers are a 5 ohm resistor, a 4 ohm resistor, and a 6 ohm resistor. 5 and 4 give you 9, 9 and 6 give you 15 ohms of total resistance. Making sense so far? That's what goes right here. Total resistance for this here circuit is 15 ohms. Well, what is this 50 volts that I was given? Where does that fall on my chart? That's our VT. That being said, what seems like the next logical easy step? Let's get the I total. So I total would be V total over R total. V total is 50. R total is 15. 50 divided by 15 is an awkward number of 3.3 amps. That's okay. We're not scared of awkward numbers. I'm going to go ahead and plug that in. But how does that work? If I know that 3.3 amps is right here at the battery, that's the total amount of current, what is true? Are there any other things on this picture that would also be 3.3 amps? Which ones? R1. In other words, if I were to highlight this in yellow, the part that I'm going to highlight in yellow is the series part of the circuit. And since that's the series part of the circuit, it means all the electricity goes through it. So I agree that I1 will be 3.3 amps, and I5 will be 3.3 amps. Which opens up a whole other avenue. What does it look like we should do next? Find the voltage here and the voltage here. So V1 would be I1 times R1. I1 being 3.3 amps. R1 being 5 volts. That calculates out to be 16.6 volts. That's our V1, so I'm going to fill that in. 16.6 volts. And then we're going to do the same process for V5, which is I5 times R5. The I5 is the 3.3 still. The R5 is 6 ohms. 3.3 times 6 ends up giving us just about 20. Yeah. Right there, it's about 20. What's the risk of rounding things too early on this? Like I just rounded that. Is that dumb? I probably wouldn't if I was doing this on a test. I probably wouldn't round it because if you start rounding here and then you use this number again for something up here, you end up getting more and more rounded. And your answer gets further and further off. So I probably wouldn't round it on a test. But I did right now. Okay, so where do I go from here? Well, here's the step where you have to say that voltage gets used up as you go around the circuit. So, if I start with 50 volts, let me write this in red here. If I come out of the battery right here and I'm cruising along with 50 volts, how much gets used up here? I'm looking, 16.6, so I minus 16.6 volts. What do I have left going this way? 33.4 volts. But be careful. Normally, we just said, oh, so these are all 33.4 volts, and we're done. But this part is in series too. So in reality, we're kind of going to do this out of order, but in reality what happens is that we get some used up here, and we're going to get some used up here, so how much gets used up here? So what if we take 20 more off of the 33.4? What do we got? 13.4. So the amount that goes down each of these is actually 13.4 volts. Do you see why I did that? I had to account for this one. I couldn't just ignore it because it's in the series part. So now we know that each of these is 13.4. Ish. And how do we find our currents? So, for instance, for I2, we do V2 over R2, I3, V3 over R3, and I4, V4 over R4. The V's play out like the same each time, so 13.4 volts, 13.4 volts, and 13.4 volts. And the R's play out as 10, 12, and 15. Which means the currents are as follows. 1.33, 1.11. If you totally disagree with one of these numbers, yell out. 0.89. Are your numbers close to that? Off by a little bit, but that's again the rounding thing. We really shouldn't round much. And so at this point, I have found all of the parts of my combo circuit, and now someone could ask me, well, if I put an ammeter right here, what would it read? And I would simply say, okay, that's R2, so that must be I2, so that must be 1.33 amps. So you could put a voltmeter or an ammeter anywhere on this picture now, and all you gotta do is come down to your chart, and I can tell you, or you can tell me exactly what voltage or current it would be reading. So for today,